Okay, here we are on question 2, the first practice test. We're going to work part A here. Make a note of that. And before I forget, this part A is going to be worth 3 points total. And here's how we solve it. Twice differentiable, pay attention to that, sometimes that's important. F, is defined for all real numbers and satisfies the following conditions. Okay, keep going. Function G is this formula. Remember, A is going to be a constant. Yep, they tell us A is a constant. Find G prime of 0. Stop right there. Let's do that first. So G of x is e to the ax plus f. Therefore, G prime of x, the derivative of e to the something is e to that something multiplied by the derivative of the something. This is over dx because this is taking the derivative of g of x, so the input variable is x, plus the derivative of f is going to be f prime. This is going to equal, a is a constant, so this is the derivative of, like ax, like 2x. The derivative of 2x would be 2, so the derivative of ax is just a. And I'm solving this by using concepts, not by trying to remember some other problem that happened to be similar. So I'm supposed to find g prime of 0. So that means I've got to plug in a 0 for x. 0 for x, not for a. Should use parentheses when you're replacing the x. You don't know the value of a, so don't worry about it. E to the 0 is 1, so this is just a. Although if you left it as, you have to work out this. They wouldn't want you to leave that, a times 0. They probably want you to put 0. But you could write e to the 0, that would be fair, but a is a little easier. F prime of 0, they told me up here is negative 4. So I stop right there. And by getting that far, they're going to give me 1 point. So now it says find g double prime of 0, in terms of a. There was a period. I probably should have gone to the period. So I've got my formula here for g prime of any x. So what I need to do is take the derivative of that formula. Don't need to use the product rule because a is a constant. So g double prime of x, the multiplying constant a just comes along, and I would have the derivative of e to the ax plus the derivative of f prime of x is going to be f double prime of x. So then g double prime of x is going to equal, we've already done this one. It turned out to be this right here, which was just a e to the ax. So I've got an extra a. They multiply together. That gives me a squared e to the ax plus f double prime of x. And they gave a point if you got that far. Supposed to find g double prime of 0. So I write g double prime of 0 is going to equal a squared e to the, I didn't need parentheses there, but whatever. So g double prime of 0 is going to equal, this again is 1, so that's a squared. You do have to figure out what f double prime of 0 is, but they told us. So this is a squared plus 3. To get that far, I get one more point. Or as we said at the beginning, total of 3 points. Okay, now we're on part B. And part B is worth a total of 4 points. Okay, function h is given by this formula. K is a constant. Find h prime of x. I should stop there and do that. So I write h prime of x. Okay, this is one function multiplied by another, so I have to use the product rule. It's going to equal the second function f multiplied by the derivative of the first plus the first function multiplied by the derivative of the second. So now h prime of x is going to equal f of x. Okay, using Susie's circle, the derivative of the cosine is -1 times the sine. Don't put a negative there, it looks like you're subtracting. You need parentheses. So, negative sine of kx multiplied by the derivative of kx. Plus cosine of kx, and then the derivative of f is just f prime, like that. So one more line will have it. So h prime of x must equal, let's see, the -1, probably easier to write it out front. So we're going to have -1 times f. The derivative of kx is going to be just k. This is good enough. It doesn't have to be in any order because it's multiplication. Then sine of kx plus cosine of kx f prime of x. To get that far, they're going to give me 1 point. So then, so we found h prime of x. Now it says, and write an equation for the line tangent to h at x equals 0. And small mistake here. They actually give 2 points for this, meaning if you didn't get to this spot perfectly, but you did part of it right, you would get one of the 2. Okay, now we're supposed to write the equation of a line tangent. So I go to my golden notes, I get my picture. I'm going to need this equation here, but I won't need all of this. We'll do a little erasing. So we won't need this work anymore. Not too much there. We are going to need this. This is kx. So this is the graph of h, because we're writing a line tangent to h. h there. So this is the point where x is equal to 0. That means this is h of 0. And that means the slope right here is h prime of 0. H prime when x is 0. So I use my formula right here for h. I go find h when x is 0. This is where I needed that. You can use your calculator or just use the chart I gave you that shows that the cosine of 0 is 1. F of 0 is 2, hence 2. So I found this. This is 0, 2. Now I need to go find h prime of 0. So that's this equation. Multiplied by k. I don't know the value of k, so just keep working. As long as I'm writing, I'm not stuck, so I'm good. Here's where I figured out. Because on that chart you see that the sine of 0 is 0, so 0 times all this is still 0. So that's going to be 0 plus cosine of k multiplied by 0 times f prime of 0. So this is going to equal, cosine of 0 is 1. F prime of 0 is negative 4. So this is 1 multiplied by negative 4 or negative 4. So that's my slope right here, negative 4. They gave another point for getting to this juncture right here. So we had 2 points for getting that far. Here's my third, the fourth and final point. Remember, 4 points total. Fourth and final point is going to be for my equation of the line tangent. So my slope is negative 4. X minus the x-coordinate of 0 plus the y-coordinate, which turned out to be 2. That's going to give me the last point of the 4. Okay, again, as I mentioned in the email, I want to make sure that the practice tests are hopefully more challenging than the real test. That is tricky because there's no way to predict what they'll ask, but I am trying to perhaps make I'm trying to make the practice tests have a few more concepts tested, perhaps feel like it take a little more time. Part of that's to get you used to skipping things that are hard or you're stuck on. Remembering that you don't have to answer everything to get a 5, so you want to practice skipping. But anyway, here we go. It's a limit problem. Doesn't mean we have to use L'Hopital's rule, but there's a pretty good chance. But I look at my golden notes. It's not x approaching infinity. Well, let's write this down. We're doing part C here. And this is going to be worth 2 points total. So we're not approaching, x is not approaching infinity. These don't divide, remember, because 2x is not a factor of the numerator. So don't think that divides. So we can't do that. So we check left and right. So we think of plugging in when x is close to 0. So this is going to be 1 minus, cosine squared means the cosine being squared. So when x is close to 0, cosine's close to 1. That's what it said on that chart. 1 squared will be close to 1. So that top's going to get close to 0. The bottom definitely is getting close to 0 because we have that. So because we got 0 over 0, when we tried to find our limit, we're going to use L'Hopital's rule, which says our original limit's the same as this limit. So we've got to go find set up our thing here. So we write f of x is equal to 1 minus cosine squared of 2x. So f prime of x is going to equal 0 minus, bring down the 2, cosine of the 2x, and all of that gets raised to the 2 minus 1 power. Did these earlier in the year. Multiplied by the derivative of the cosine of the 2x. You always take the derivative in terms of the input variable, or in L'Hopital's rule in terms of the limiting variable. So now you have f prime of x must equal negative 2 cosine of 2x. The derivative of cosine is negative sine of 2x. You can do a lot of this in your head. You don't have to write it all out. Just doing that for the video. So f prime of x is going to equal this negative 2 times this negative 1 will make a positive 2. But the derivative of 2x is just 2. So that's going to become positive 4. And it will be cosine of 2x multiplied by the sine of 2x. They'll give you a point if you get to there. If you show that you're taking the derivative of the numerator, that was a bit of work. So then, the derivative of the bottom, so our g is quantity 2x all being squared, which means g prime of x is going to be, bring down the 2, multiplied by the 2x, raised to the 2 minus 1, multiplied by the derivative of the 2x. So our g prime of x is going to equal 2 multiplied by 2x, because 2 minus 1 is just 1. Derivative of 2x is also 2, so I'm going to get 4 times 2x. Which is 8x. So copy this over. Then, so we've got our g prime here is 8x, and our f prime is here. So we create a new limit problem. So clear all this off. So now we're finding the limit. So this limit, as x approaches 0, of 1 minus the cosine squared of 2x. That's the same thing as over 2x squared. That's the same thing as the limit as x approaches 0 of 4 cosine of 2x multiplied by the sine of 2x, all divided by 8x. And the problem now is when we try to take the limit again, we're still going to get 0 on the bottom, and we're still going to get 0 on the top because the sine of 0 is going to be 0. So they're giving us a difficult problem here. We have to use L'Hopital's rule twice. So I have to take another derivative. Good news is, though, the derivative of the bottom is going to be 8, so that will help. So now I take the derivative of the top using the product rule. So that's going to be the sine of 2x. Remember, the 4 just tags along being a multiplying constant. Derivative of the cosine is the negative sine. We've done this already. Derivative of the cosine is going to be negative 2 sine of 2x, close parenthesis, plus the first function, 4 is just a multiplying constant, multiplied by the derivative of the second. The derivative of the sine is the cosine, so that's going to be 2 cosine of 2x, like that. So my new limit problem is, this limit's going to now equal this limit. Now this was a pretty rough L'Hopital's rule problem, but I felt like it was a good choice for a practice test. On the actual test, I believe they would give you more than 2 points. But again, I'm trying to simulate a test that is more difficult than what you will encounter. It's better to prepare with something that's a little bit harder. So now when we plug in close to 0 here, this is going to become 0, this is going to become 0, plus this will become close to 1, this will become close to 1, so that whole numerator is going to get close to 8. The denominator is going to get close to 8 because the derivative of 8x is 8. That's why the limit's going to equal 1. I'm going to write that out again, though, because I kind of ran out of space here. So what we would have is, and again, I believe they would want you to show how you're going from one limit to the next, because that's what L'Hopital's rule means. But actually finding the limit, the value you're looking for is 1. If you find that value of the limit is 1, give yourself one more point. So now when I take the derivative of the top and the bottom, I'm going to get this. The limit as x approaches 0 of this big mess here, 4 negative sine of 2x multiplied by 2 sine of 2x plus 4 cosine of 2x multiplied by 2 cosine of 2x, all divided by the derivative of 8x, which is just 8, and that limit does turn out to be 1, which gets you one more point. Okay, part D. Part D is going to be worth a total of 2 points. I tried to make this, the retake practice test, as I said, have perhaps a bit, little bit more, few more concepts tested to make the problem just a little bit more challenging. Also get you used to the idea of skipping things. This is part D. I also made the scoring exactly the same as the practice test we've been working on, so that you were accustomed to the scoring and you had something to compare to from your previous work. That's why the total for part question 1 and question 2 is still going to add up to 27. So 2 more points here. They want us to find h prime of 1. So take the derivative. So h prime of x, it's the product rule. So it's second function multiplied by derivative of the first plus first function multiplied by derivative of the second plus 2 is a multiplying constant. The derivative of g is g prime. Now we can plug in the 1. So So we have g of 1. 1 point for getting to here. G of 1 times f prime of 1 plus f of 1 multiplied by g prime of 1 plus 2 times g prime of 1. So h prime of 1 is going to equal, look up, g of 1, negative 5, f of f prime of 1, f prime of 1 is negative 4, plus f of 1, 1 still, f of 1 is 2, g prime of 1, still 1, g prime of 1 is 3, plus 2 times g prime of 1 is still 3. And we really should stop there and collect our point, because you don't have to go any further. If you went further, it would have turned out to be 20 plus 6, which is 32.